My name's Colin Kil Corfield. I'm also a professor at the University of Cambridge. My area of research is fluid mechanics, and in particular the fluid mechanics of the global climate system. My particular interest is to use sophisticated modern mathematical tools to improve our modelling of the global climate system, the areas where it's really hard to be able to predict how the climate will evolve over the next decades, because the processes happen on very small scales, and yet they affect the whole planet. And so that then means that there is a very interesting question about what is the best way to allocate resources between trying to make your physics-based model have higher and higher resolution on smaller and smaller scales, but you will still always be uncertain, or use modern data-driven methods to actually, in some sense, cut a corner and allow yourself to actually have a better predictability by using data-driven methods to improve those parameterizations, or even improve the way you describe those processes by identifying some underlying physics from data that your models don't actually capture because you weren't aware of them. So what I've described, my original motivation, my original curiosity has been understanding turbulence in the world's oceans. What you're really trying to do in what I've described is identify models for extreme events, commonly referred, I think, in economic circles to the black swan. You want to understand how likely an extreme event is and what the properties of those extreme events, which could completely swamp the normal event, the normal situation. I think this has a major relevance in particular in the insurance industry. It's indeed obvious, right, to do with cyclones and storms and flooding events. Therefore, the question is, how can you, from lots and lots of data, identify the slight signal of a very extreme event that could swamp absolutely everything? And understanding extreme events has applications in understanding climate, but extreme events are a run on an institution, a rare event in an insurance community, in an insurance market, a rare event in any aspect of any financial situation can often be the real opportunity for a high profit, but a high risk moment. And so understanding how you can identify and model rare events and predict them or get statistical ideas of their predictability is interesting to my day job, but obviously has huge transferability into the commercial sector. Exactly. Once you have an extreme event, you have a storm, you have a flood, you have a big cyclone, it's already happened. But the interesting question, the question that has real skill, is can you see the very beginning, the lighting the touch paper rather than the explosion? And that is extremely difficult to do using traditional methods, but there's a lot of hints in the AI machine learning data-driven world that you can identify the touch paper that means the explosion is going to happen sometime in the future, and you kind of hope that you have long enough gap to actually do something about it. What I'd really like to get out from the collaboration with Infosys is what I've experienced throughout my career, is that curiosity-driven science can give you the tools to address really important problems in other domains. And this is the opportunity to be co-located, to learn from each other, so that the learnings that we get exploring the scientific problems that we're excited about because they're the ones that had motivated us to get into science in the first place, will also have points of connection with our colleagues in Infosys who can see the value of the tools we've developed to solve their particular problems. This is what really motivates me as an applied mathematician, that we develop tools that allow us to address problems of importance And I'm particularly obsessed with understanding turbulence in the ocean, but understanding turbulence in the ocean and heat transport in the ocean uses the same tools that you need to understand extreme events in any other number of sectors. And some of those sectors are highly likely that our colleagues and friends in Infosys will say, that tool is useful for this.